Right, it's the next morning. I get out and have another go last night, but I'm going to set up and use my turning tool just to get that cleaned up and get the face cleaned up. And we'll leave material on here to get that that radius tool into place. We'll see how we go. As I said before, this diameter isn't a working diameter. It's not a critical diameter, so if I come undersize, it's not going to hurt. There's no max diameters for the housing that goes into this, so taking a bit more off that OD isn't going to hurt at all. Alright, it's starting to clean up alright. Just keep inching it in. Travel in the saddle. Just get that lightly cleaned up as well. I'll just readjust that tool so I can get a little bit more travel out of it. Just do one more fine lick on that face. I'll come in with a radius tool and we'll tidy that up a little bit. face has got a fair bit more that needs to come off it. I might just set up, see what, that radius looks really good. I might just clean that up with a bit of emery. Not worried about putting the tool in there. That's I've surprised myself. Alright, we might set up and we'll run a bore in there just to clean that weld out of there. I've got a fair bit of meat in there that does have to come off. Just try and get that around just a little bit further. Well, the actual finish size on that is 71 millimeters. We're at about 66, so another 5 millimeters needs to come out. I might just take a little bit more out of there while it's in the lathe, because I will be boring this and I want to try and get a lot of that intermittent cutting away. My boring setup going that length isn't real stable, so we'll get this basically cleaned up while it's in the lathe. Now it's not going to be dead set concentric, because obviously when I start machining the envelopes on this, those centers are going to change slightly, but if we can get it 90% there, saves us a lot of work on the borer. The boring head, I should say. Right, I'm just going to go outside and we'll weld this up. I actually made up another one of these. I want to have a bit more of a machining allowance, so I've made it 17 millimeters long rather than the 15. Gives me a couple of mil to bring it back. I've still kept it at the 16. Depth isn't going to be a real issue, but I want a little bit more to clean up off the back in case you get a little bit of a bow in it. I've also machined on a couple of weld preps. Weld preps don't go all the way. I've given them the middle of this. It's going to be a bit hard to try and get in there with a stick to try and weld that. I'll probably make a big mess of it anyway. So we'll just run it up there, down the sides and across the underneath side as well. And I'm going to use a bit of that anti-weld spatter. I've got some there, spray can of stuff, and I'll spray that on there to try and give it some more protection against the spatter, because it really makes a mess. So Alright, well we'll go outside, we'll set up, and we'll get this welded in place. This is the last bit of welding I've got to do on this housing, and then thank goodness it's all machining after that. Alright, so we just completed that weld up, and that's come up pretty good. Pretty good. It's still pretty hot. I've just done welding. I did some pad welding in the back there just to build it up. That's all going to get machined back. And the anti-spatter spray, goodness me, that did a really good job. Except the spots I didn't get at. Well, I can get to that fairly easily and get that tidied up. But no, I'm really happy with that. It's worked out. It's worked out pretty well. So, yeah, I'll get in there with a little ball mill and just run down there and just tidy all that up, make it look good. But thank goodness that's the last of the welding done. Alright, now to the fun stuff. Before I pack it away, I thought I'd just show you the little welder that I'm using for this job. It's a little one of the Chinese supermarkets, Banggood I think it was, little used well. I have absolutely given this little thing a flogging. I did, if you ever saw my videos on the lifting of the slab in my workshop and all the big structural strongbacks I had to make up, this little welder did most of the welding on those. And you know, this thing would run 8 hours a day without even missing a beat. Didn't even turn off to cool down, it just kept going and going and going. So, you know, for my money, apart from the fact that the handle's been put on crooked and it's got a fair old ding in the back there where it got smashed in during transport. Other than that, I think this cost me, just with a note, a credit coupon, I think I paid just over $100 for this. Worth every cent. Beautiful welds. You can put down the 3.2mm sticks. Huge burn if you're not careful. Yeah, great little unit. Really impressed with it. Really impressed with it. And that's the anti-spatter stuff I used, and often don't think these things work, but geez, it worked really well. Certainly kept the plating nice and clean on it. So anyway, I thought I'd show you this little thing before I pack it away, because hopefully I won't be using it for a little while. As I said, it's not my forte welding. I'm not very good at it, but this little thing makes it so much easier. Alright guys, see you soon. It's starting to come down, cats and dogs again. Well, I just thought I'd bring you back to show you what we're doing here. I'm just going to clean this up with a bull nose cutter or a ball end cutter. I've got lots of names. These are just high speed steel. These things here are a little bit fickle. Obviously at the centre of the cutter in the ball you've got zero velocity, so they tend to rub a fair bit, so you've just got to take it really easy with these. But I've done one little pass through there and it looked fairly reasonable, so we'll do a few more and get it back. Right, I'll keep going with that, and I'll bring you back when we're finished and you can see the results. Alright guys, well, we'll show you the end result of our bull nose cutter. So that's cut really nice. It's got a little bit of weld undercut in there that you can see, probably maybe 1/4 mil, if that. If I do go ahead and paint this, I'll put a bit of spray putty on that and tidy that up. But yeah, the bull nose finish has brought that up nicely. I've also given that a lick across the top. It ended up taking over just over 1/2 mil off that. Obviously with the heat it's bowed in a little bit in the middle. So that's all come about really well. So that's the finish of the welding on this housing, thank goodness. So now we're going to start setting up to do our machining of our envelope sizes. Getting that all down to size, ready to set up datums for all of our
our boring and our line boring. So they're going to be some interesting setups to get that all in line. Once that's all done, obviously we've got a lot of other components to make up that go to make up this this slotter head. A lot more work left on this though. A lot of drilling and tapping, machining. So we've got heaps left on this little housing. So we'll keep moving on with it. One thing I did forget to mention, that little welder, that little used well welder. If you ever go to Xanadu's site, Rob, he did a great little review on that welder, and that was the main reason I bought that. It was based on Rob's review. So no, all in all, it's a great little unit. So get over there, check out Xanadu's with an X. Check out his site and have a look at that review. It's worth it if you're looking for a very cheap, every now and again use welder. It's going to give you some quality results. So, all right, guys, we'll be back soon for the fun stuff, machining. Hi guys, came back again. It's been about a week since I've finished up this weldment. We've had some other things on the go in the workshop. So we're going to get back and start doing the machining after we've completed this weldment. Now, as you've seen, we've done some pre-machining on this. We've got some pre-machining on the rear end. On the compensating ring, we've got some pre-machining done on the face here and on the side. So we've got some rough machined faces that we can start setting up our machining process to. One of the important things we need to do before we do that is to do a quick survey as to where everything's sitting at the moment. And for me, I know it's on a rough weldment at the moment, but I like to sort of get a bit of an idea where things are at so that I can start planning about how I'm going to do that machining. I just use these little buttons inside here. They're exactly 20mm in diameter. Drop my height gauge down after I've got a reference either off the table, or I've set them up on parallels and referenced it out. So I've gone over this and had a bit of a look and see where everything is laying at the moment. Important thing is to work out what feature or what datum I want to use as a reference to set up all my other machining operations on this job. And for me, it's going to be this board here, which is where the bearing is going to sit for the actual worm. Those bosses we've welded in, when we get them back to final size, we've got, 3.5–4mm wall thickness in there, so we haven't got an awful lot to play with. So I'm going to use that as my reference, and that everything can follow off that. I've got plenty of meat on the front face here. I've got plenty of meat in the rear here. I've got plenty of meat underneath and on the top. So I've got meat around that I can work to keep them as concentric as I can. Now I have gone through and done a quick little check on these just with my buttons in there. Come down, done a reference first of all to make sure that they're actually parallel, and they're parallel within 0.1 of a mil. Now I know it's on a weldment, but it gives me a little bit of comfort that they're all within a ball's raw. From centre to here and centre to the face of the compensating ring, I've got plenty of meat to play with, so I can move that around and be fairly comfortable that that's going to suit. Centre here to the centre of the bores, once again I'm within about 0.2, so I'm pretty happy with that. With the bores, centre to the edges, this one here 61.5 on one side, 61.3, 71.4, so within 0.1 of a mil on a weldment, so I'm fairly happy with that. Different story on the compensating ring at the back here. I'm out by about 0.7 to 0.8 of a mil. I'm actually low here and high here. Now I've got that housing that's going to fit inside here, and I could leave that where it is, but aesthetically it's not going to look concentric on that ring. There's a couple of things I can do to fix that up. I can do a remachine on that ring and just bring it back a little bit. That's not a working dimension, so I can comfortably do that. The other thing I can do is to bias the machining on these faces here. Remember, we made the bosses a little bit longer, so I've got a little bit more room to work with there, so I can come up, take a minimum cleanup on that, and take the remainder of the cleanup or machining back on that face there to pull that edge in a little bit. So that gets concentric from the ends down to the center. Because I've got no real features attached to this, where that bore comes in, isn't really going to be a concern to me. I'm just going to bore that out. Might just bore out a little bit. There's an elongate to start with, but then it will true up. And as I said, we'll get that true to the edges that we've set to the center line of that compensating ring. So for me, it's important to go through and do a survey of where I'm at before I start my machining. So at least I know I'm within a bull's roar of everything, and I know what I'm up for and how I'm going to go ahead and bias that out. So doing pre-surveys, I find is important. It starts getting the process in your mind as well as to how you're going to set that machining up and where you're going to start. On big stuff, you might have a big gearbox, you might have a large bridle set, big structural fabrications, lots of machining, lots of distance between features or bores. For me, it's important to go out and do a survey on a weldment before you're setting up to do the machining. So I'd often go out there. I had jigs that I'd made up for piano wire that I could string into bores and pull them out to an anchor, and just with a ruler measure around the bores on either one, set up a datum. I could drop plumb bobs down. I could do offset centers, and I can work out where all the features are that are relevant to a bore that I've set up as a datum. And it gave me a little bit of comfort that I knew that everything was right to go to that next stage. And I'd always try and involve either the machinist who's going to be doing that job, or at least the leading hand off the floor, and work together through the drawings. And we look at the process that's going to be followed for setting up datums. There may be multiple setups required, where we would set up datums that we would reference back to, what processes he would follow to go through that, and we'd work through that. And that gave me a little bit of a comfort that the leading hand or the machinist was starting to get that process into his mind about how he was going to set that up. And more importantly, it sets up a relationship between you and the fabricator. He knows that if there's any issues, he can get straight on the phone, give you a bell, talk through any problems that might happen during the machining process or before the machining process. So, always make yourself available to go out and have a talk to your fabricators. And during the machining, just pop out, just see how things are panning out. Have a talk to the machinist. What issues is he having? Is there better ways that we could have done this job? So, to me, that relationship was important. I learnt an awful lot doing things that way, and once again, you built that relationship up with your fabricator, and you knew that you were going to get a good job. It gave you confidence. You could sleep at night that was going to be the case. Surveying, as I said, I'm a very visual sort of person, so I like to use piano string lines. I like to use plumb blobs. I used to like using string lines. I like to lay things out so I can see them very visually. You can get surveyors that will come in and run a 3D scan. They're fairly expensive to get done, and I have seen some disastrous results with 3D scans. If you're getting a 3D scan done, whether it's on a piece of equipment that you're having fabricated or it might be something out in the field that you're aligning up to, go out to the site with the surveyor and run some comfort dimensions for yourself. Now, I know it's old school. Drop some plumb bobs down, run some string lines out. Just do some comfort dimensions to confirm that when you get that back and you look at that cloud, that what you're seeing in that cloud is pretty much indicative of what you've seen visually with your quick little layouts. And alarm bells should start to ring if things aren't adding up. If you're picking features out that aren't quite right and trying to use them on your model, alarm bells should be ringing if things aren't marrying up with what you've seen on the site. You can do optical surveys as another way of doing it as well, and that's a fair bit of setting up to do an optical survey on a big piece of gear, but very well worth it if it's a fairly complicated piece of gear to run with. So horses for courses, I personally like to go out and do it myself if I can. If I can't, as I said, involve a survey company to come out and do it, and be on hand with the survey company and watch the process that they're following through, and just be comfortable and confident with how they're running that setup, because it's so much easier and less expensive to pick problems up before you start getting hours put into a job. It starts to really become expensive if you find down the track that something's not right. And to backtrack and repair it can be an absolute nightmare, and sometimes it's got to be scrapped. So it's important to go out, do those initial checks, get some confidence, talk to your fabricator, get that relationship happening, work through the drawings, work through the processes. Everyone feels so much more comfortable at the end of that. Another thing I want to touch on is a question I got asked in one of my previous videos on the swing extender for the lathe, where I had that large faceplate that I made up and I fabricated and I stress relieved it. And the question was around stress relieving and what's it all about? Why do we do it? On a small item like this, I wouldn't worry about stress relieving unless it had to be done within microns, but normally for what we're doing, I would stress relieve. It's fairly stumpy, it's very solid, it's got a lot of guts around it. It's not going to give a great deal of movement, and that's what we try and prevent with stress relieving. Stress relieving is a process where we want to prevent any creep in that weldment, in that fabrication. And believe me, if you have a large fabrication and you machine it up, I can guarantee you that in 12 months time, 18 months, 2 years time, you'll have found that things will have moved, things will have relaxed, and things will have moved. So stress relieving is to stop that creak and stop that movement and to stabilize the fabrication, whether it's a fabrication, whether it's a forged lump of steel that you're fabricating a large mandrel of, whether it's a casting. Important to spend that extra time and extra money, and it's not that expensive, to get something stress relieved to make sure that it's not going to creep. And sometimes it's absolutely critical on gear. Large punch sets with very large throats, taking sample sets out of steel and aluminium sheets. I'll sometimes go through 2 stress relieving processes after initial machine, a roughing machine, a re-stress relieve before the final machine. Stress relieving is there to stop that creep. I have seen examples where stress relieving hasn't been used, and on a gearbox, and the housing did move, and it caused an awful lot of biased wear on the gear sets, and then a lot of damage following on to the bearings. So simple stress relieving process would have prevented that. So stress relieving is there to stop creep. So there's a number of processes you can use. The most common one is going to be a heat treat type stress relieve, and that will involve the fabrication going into a furnace. There's a set temperature rate or temperature rise that you'll nominate. There's a minimum and upper temperature range that you'll allow that fabrication to soak at. I think I was around 580 to 620 for memory. There's a set period of time that you will let that soak for, depending on the maximum sectional thickness. So an hour for every 1 inch of sectional thickness. And then there's a cool down rate in that furnace, and then there's a temperature at which you can remove that out of the furnace or open the doors up. So that's a heat treat stress relieve. There is age stress relieving, where you can do a fabrication, go and throw it out in a paddock for 5 years and let it stress relieve on its own and let it work on its own. I know Rolls-Royce used to do that with a lot of their castings or their block castings. They'd cast them up and throw them out in the paddock for a number of years just to self-relieve. There's ultrasonic stress relieving, where you can put probes on that will vibrate at a set frequency to relieve any stresses in a fabrication. Some people believe in it, some people don't. There's the old-fashioned way. If it's a small job, ball peen hammer, just peening on the welds will do the same sort of thing. That will relieve it out as well. But for me, heat treat stress relieving is the way to go, and I've seen absolutely no issues when that process has been carried out. But that's a long way from these little things. So let's go ahead and we'll get this set up, and we'll start our machining process. My initial plan on this is just to just lightly lick everything all over, the machine faces all over, get everything squared up first of all, then do another survey, see where we're at, and see where we're going to bias those machine outs. So that's the way we're going to run this little job, and we'll move on from there. So it's going to be an interesting little job, this one. Feel the gotchas, but yeah, looking forward to doing this one. All right, we'll catch up with you soon.